Hey everybody, in this video we are kicking off our big limits unit, and our first lesson is going to go into a review or explanation, if it's new for you, of piecewise functions, because piecewise functions are a really great way to get into the discussion of limits. It's really they showcase a lot of great discontinuities. They can be whatever we want them to be, look however we want them to look. There's a lot of flexibility, and that's because of this following definition. A piecewise function has different rules for different parts of its domain. So we're going to get into example 1 in this unit in lesson 1. So Leila went on a bicycle trip. The graph shows the relationship between time and distance traveled by Leila. Write a function, distance of time, or d of t, for her distance in miles traveled in terms of the time t in hours. So it's set up for us d of t equals, and we have room for 4 pieces of this piecewise function. So where exactly is this graph? Well, it's over here. Okay, so here's Leila's bike ride. So let's see what we got here. We're going from this spot right there to this spot right here, and I'm going to decide to make that an open circle just so we can write our piecewise functions how we want. Now this looks like it's created by all linear pieces. So here I'm going from 0 until 1. So I'm going to use that interval on the side here. So here, what will I have? Well, it looks like the equation is 3t mx plus b. So my slope is 3 up 3 over 1. My y-intercept is 0. And I'm going to use interval notation, and it's going to go based on how I drew it from 0 until 1, with a bracket on the 0 to include it and a parenthesis on the 1. Next, this next piece here, I'm going to color in this one, and this is all just personal choice, and I'm going to leave this one open. Now, what a lot of people notice is the slope is 2/3. So they're like, oh, my equation would be 2/3 t. However, if it was 2/3 t, it would be coming out of the origin. We're kind of forgetting about some changing around. Now, if I tried to write this in y equals mx plus b, which everybody loves to do because we are silly, we're going to have an obnoxious y-intercept. It's going to be not a whole number. Who wants that? Not me, not you. So how do I work my way around that and avoid having to deal with that? Well, I'm glad you asked. So what we're going to do is we're going to draw in a parenthesis there. I'm going to choose this spot right here, okay? And I'm going to make this position, this spot, that ordered pair, I'm going to treat it as h, comma, k, as in my transformations when I would shift my functions left, right, up, down, yada, yada. So I'm going to use that as my hk. So it went to the right 1, and then it went up 3. So if it went right 1, I'm going to have minus 1 in the parenthesis. Up 3, I'm going to have plus 3 on the side right there. And that is the second piece of the piecewise function, and I avoid having to deal with mx plus b. There's no one that said we can't have it in a different form. Who the heck really cares? So now I'm going to go from the 1 over here until it looks like we're going until 4. So from 1 to 4. And I colored in the 1, so we're going 1, comma, 4, and the 4 has a parenthesis. Okay, next piece of the piecewise. Let's color in here. Let's go ahead and make this a nice bright blue line that we can see. I'm going to leave this spot right there open. And I'm going to be analyzing this little horizontal piece, this little horizontal segment from 4 until, what is this, 7? Yeah, 4 to 7. 4 closed, 7 open. So 4 will be closed and 7 will be open. And that right there is just 5. We don't have anything else going on. I mean, really it's 0t plus 5 because it's rise 0, run whatever the heck you want. And that's what makes a horizontal line. All horizontal lines have a slope of 0. All vertical lines have an undefined slope. Don't forget that. Very important, especially if you plan on taking calculus. All right, last but not least, we have this piece here. Now this one we're going to color in both the first and last point. So these are both going to be colored in. It's going to go right there. It's supposed to be solid. I mean, not solid. Well, it's supposed to be a straight line. It looks a little curved. And it looks like here we're going from 7 until 10. And okay, what's my slope? Up 1, 2, 3, 4, 5, and over 3. And now this time I'm going to use this guy as my new HK. So what did I say? Up 5 over 3. So 5, was it 3? Yeah. 5 thirds T minus 7 plus, I already forgot, up 5. And I'm going from 7 until 10, and they're both going to have a squared off bracket. And that right there is your piecewise function. Now it asks us to find the D of 3. So what we want to decide is like, what do these words even mean? Or what does this math even mean? So this is really saying the distance Leila traveled after 3 hours. So that's what we're looking for. Now what do? If I try to just do this from the graph, here's 3, and I try to go right here and get that point, you're going to see, like before, I'm going to get some gnarly fraction. I don't really know what that is. So we're going to try to do it algebraically, not just from reading the graph. So if I want to find actually D of 3, and I have 4 equations to choose from, how do I pick? You pick the one that 3 is in your domain. So since 3 is between 1 and 4, I'm going to plug it into my green equation. So that means I have 2/3 times 3 minus 1 plus 3. 3 minus 1 is 2. 2/3 times 2 plus what? 3, which is 4/3 plus 3, and 3 is really 9/3. 4/3 and 9/3 is 13 miles. So it's really 4 and 1/3 miles. Woo! Okay, good job, Leila. So 4 and 1/3 miles is the final answer. Really, it's 13 over 3. We like an improper fraction, but just for a little context right there. And that's the end of the example 1 in lesson 1, which is piecewise functions. We're going to get into a few more examples with piecewise, and then we're going to get into a nice intro to limits. So hope you got that down. Hope you found it easy. If it makes you happy and you loved it, thumbs it up. If it doesn't make you happy, if you're mad, you could put a thumbs down. But I hope that you're happy. All right. Questions, comments, concerns, feedback, requests, put them in the comment section below, and I will try to do whatever it is you guys need. So, adios. Bye for now.